Hello, welcome to our Chapter 4 audio and video lecture on cycloalkanes and their stereochemistry. If you're wondering why it is that we have an entire chapter devoted to cycloalkanes, or alkanes that are formed into a ring, it's because there are certain specific consequences to having functional groups in a ring as opposed to in an open chain. We'll talk quite a bit about the constrained freedom of movement that a ring introduces. The fact that there are now two different faces to the ring will be important to us. Also, it's important for you to know a bit about these cyclic structures because many biological molecules contain one or many rings in their structure. Take a look at cholesterol with 4 fused rings. 6, 6, 6, and 5 membered rings fused into its structure there. Prostaglandin E1, a very important hormone, has a 5-membered ring with these big long alkyl chains coming off of it, but its core is that 5-membered ring. So a lot of very important biological molecules have these ring structures right at their core. So let's talk about cycloalkanes themselves. From our discussions before, we talked about saturated, so they will have all of the hydrogens that they can possibly hold, so it's going to be single bonds when we talk about cycloalkanes. They're cyclic, which means they just go around in a circle. So rather than being open chain, that's the opposite. Regular open chain alkanes have all the freedom of movement they like. They can rotate around all of their bonds, but cycloalkanes have a cyclic structure. So the names of cycloalkanes start very simply: cyclopropane, cyclobutane, cyclopentane, cyclohexane for 3, 4, 5, and 6 membered rings. When we're drawing the line structures for them, we just draw them as polygons, pretty much. 3, 4, 5, 6 membered rings. Just draw on their simple structures from above. Just draw a 6-membered ring as a hexagon. Their general formula is ch2 multiplied however many times, because when all we have is just a ring, then it's a carbon with 2 hydrogens repeated across the entire ring. So ch2 all times 4 gives us cyclobutane. So cyclobutane is C4H8. Right, cyclohexane C6H12, so twice as many hydrogens as carbons. We'll take a look at their 3-dimensional structures viewed from the side in just a little bit. There are some important consequences to that.